welcome back students. In today's class, we are going to start this finite dimensional spectral theory. Finite dimensional spectral theory के अंदर हम आइगन वेक्टर, आइगन स्पेसेस के बारे में पढ़ेंगे एंड इनर प्रोडक्ट की हेल्प से इस चीज को और डीप में जानेंगे. ओके सबसे पहले फाइनाइट डायमेंशनल स्पेक्ट्रल थियोरी को स्टार्ट करने से पहले हम कुछ डेफिनेशंस देखेंगे इसके अंदर कि आइगन वेक्टर क्या होता है, आइगन वैल्यू क्या होती है, आइगन स्पेस क्या होता है, and then we are going to prove some results which are very helpful for us. Okay, so first of all I will explain to you what is proper eigenvector. Proper eigenvector is also known as characteristic vector or latent vector. Characteristic vector, latent vector and proper eigenvector. Since we are studying inner product space, so firstly we need to define an operator. Let T be an operator on what? On Hilbert space H. T be any operator on Hilbert space H. Okay. Then a non-zero vector, that vector which you are going to prove proper eigenvector, characteristic vector, latent vector, that should be non-zero. If it is zero, then this will not be proper eigenvector. Okay, then a non-zero vector, from where this vector will be? This vector will be from X, H. Non-zero vector X belongs to H is said to be latent vector when, if, first of all what we need to have, we must have X non-zero, कि जो हमने ये X vector लिया that should be non-zero. And what is second condition? Second condition is whenever you operate this operator T on this non-zero vector X, we must have this lambda times of X, lambda times of that vector. What is lambda? Where lambda is any scalar. And what is this lambda? This lambda is known as eigen value. All right, this X, this non-zero X is called eigenvector and this lambda is called eigenvalue. Lambda is any scalar, it can be zero. Okay, but this X should be non-zero. If it is zero, then this will never become proper eigenvector or latent vector or characteristic vector. In the similar way, this is known as eigenvalue, characteristic value or latent value. Now I will define eigen space. What is eigenspace? In this also, we firstly define an operator T. Let T be any operator on Hilbert space H. T be any operator on Hilbert space H. आइगन स्पेस नेम से ही पता चल जा रहा होगा कोई ना कोई सेट आएगा. देयर इज सम सेट. देन M is the set. Then if M is the set consisting of all the eigen vectors corresponding to eigen value lambda. See क्या कहा जा रहा है? If M is the set, M वो सेट है जिसके अंदर सारे आइगन वेक्टर्स हैं. corresponding to what? corresponding to eigen value lambda. Let me clear one thing. If you have two different scalars, lambda 1 and lambda 2, then you have two different eigen spaces corresponding to lambda 1 and lambda 2. In the same way, जितने भी आइगन वेक्टर लैम्डा से जुड़े होंगे, जितने भी आइगन वेक्टर लैम्डा से जुड़े होंगे उन सभी आइगन वेक्टर्स को यू विल पुट इन द सेट M and that set is called eigen space corresponding to what? Eigen value lambda. All right, and there are some small results which are two eigen spaces are either identical or completely disjoint. They don't have any common eigenvector. Okay, lambda 1 and lambda 2. If there are two distinct eigenvalues, then we must have two distinct eigenspaces, lambda 1 and corresponding to lambda 1 and corresponding to lambda 2. This is your eigenspace. Mathematically, how we will write it? Mathematically, what is M? M is equals to X belongs to H. All those vectors from H such that T of X equals to lambda X. यानी हिल्बर्ट स्पेस H के अंदर से वो सारे vectors and these vectors should be non-zero. Alright, these vectors should be non-zero such that T of X equals to lambda times X, where lambda is any scalar. This is your definition of eigen space. After this, in the next video, we are going to do some results which are very, very, very important and useful for us. Alright.